Right, okay, so let's do addition with negatives. So, let's do something easy. Let's do 4 plus minus 1. What should we get? 3. Everyone's happy? So we're going to get 3. Oh, so that should look like, in this format, that. Yeah? Let's see what happens. So, let's write down 4. Right, minus 1. What do we say minus 1 is in 2's complement?
1.
All the ones. Easiest number to write, that's why I picked it. I didn't have to do any flipping and adding. Right, we're going to add these two together. Anyone guess what might happen? Just by looking at it and doing it in your head for carry.
It's going to just go on forever. It's like constantly going to be carried.
You're going to roll. You roll the carry, but we'll see. And it goes in a special location. Let's just see. So it starts off, it's like, yeah, it's all right. 0 and 1 is 1. 0 and 1 is 1. 1 and 1. Aha. 0. That looks suspiciously like the right answer already, so that's good. Carry 1. 1 and 1 is not carry 1. 1 and 1 is not carry 1. But we haven't got another bit, have we? Another column. But we have got a special location inside the CPU called the carry. And whenever you do a question like this, always show that you understand that there is a carry and it goes into a special location called the carry bit. So I would always label it up and say carry. But if we look at the 5 bits, we have got the right answer in our 5 bits. Carry might not matter. Depends on what we're doing. It's actually used for what we call multi-precision arithmetic. Because the CPU works with numbers of certain sizes, so 32 bits, if we want to work with a number that's bigger than 32 bits, we would have to add the numbers in 2 parts. We'd add the first 32 bits together, and then if there was a carry, we'd include that when we add the second 32 bits. In the same way that if you've got 40 and 5 to add to 30 and 7, what you're effectively doing is you're doing multi-part arithmetic anyway. You're saying, let's just add these units together. So 5 and 7 is 2. Let's carry a 1, and now let's add the others. So you can do that with bits. So if you wanted a special program that used integers that were 1024 bits in length, so you could store massive numbers, you could, but you'd have to create your own arithmetic routines. But it's not very hard. The carry helps us. So we can use that carry, and that's all we're doing here. So we go, oh yeah, 4 and 3, well that's 7, but we had a carry from the previous operation. So we get 8 to 2. Generally, if you've got a negative number, you know the answer is going to be positive, you'll always roll the carry off into the carry bit. Okay? But that magically happened. 2's complement, the format of 2's complement made that happen. Okay? Let's just do another one just to show you it does work. Right, so let's add 4 plus minus 7. What should that give us as an answer? Yeah, everyone happy it's minus 3? Right, let's write down what 4 is. Right, minus 7, don't know what minus 7 is, so we'll have to write down plus 7 first. So let's just write down plus 7. So let's just indicate that we know that that's plus 7. Let's do 2's complement, so flip and add. So flip, 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 get to the last one, leave it as a 1. That is minus 7 in 2's complement. Let's use that. We're going to add them together. Okay, so the nice thing about 2's complement, it's weird for us, but for the computer, the number and the sign are all part of the same thing, and it doesn't matter when we do the addition. It just works. If we were to do sign and magnitude, you have to start messing about with, oh, I've got a negative, so I've got to add, or I've got a positive to a negative, so I've got to subtract. So this makes it seamless. So we can do 0 and 1 is 1, 0 and 1 is 1, 0 and 1 is 1. I've done something stupid here. Oh, I've written the number down wrong. I thought it was. See, easy to make mistakes. Always double check yourself. That was going to give me -1. That's why I thought, wait, hang on a minute, it's wrong. But again, nice thing, I know what the answer should be. Right, so 1 and 0 is 1. That's a bit better. We get a 0 there. Then we get a 1, then we get a 1, then we get a 1. Now looking at that, I don't know what the number, I know it's -3, but I don't know what the number is, but I know it's negative. Because the sign bit is 1. So what I'm going to do to find out what the actual answer is, I'm going to write down minus somewhere, because I know my answer is minus, and I don't want to forget that. I'm going to flip and add, do the 2's complement to find out what that positive version of that number is. So flip, 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 get to the final 1, keep it as a 1. It is -3. Okay. Weirdly, I didn't have any carries in that one, but that's just how it goes. Everyone happy with these? Okay. Right. Let's go back to that thing that I posed at the start. Subtraction. Subtraction. Horrible, isn't it? I'm awful. My mental arithmetic with subtraction is pathetic, but when I start doing it on paper, I'm pretty pathetic at subtraction as well. Okay. So let's have a go at just a simple subtraction. So let's do, and I'm just going to do it in decimal first. Let's take away 51. Okay, what's the process that we go through? If you were to describe, you're telling me how to do subtraction, basically. So what have I got to do first? Right, start on the units column, yeah? And do what?
Subtract.
Oh, right, okay. 6 minus 1. I know because I've got a supreme brain, that is 5. Easy. What do I do next? Take away that 10's column, yeah? Right, so 5 minus 3. Can't do that. I can't write -2 in the middle of my number, although I'm sure people have tried to do that. Anyone done that? Anyone tried to do that? No? Right, okay, so I can't do that, so what do I do? Borrow. The dreaded term. Right, so I go to the next column up, and I go, okay, let's borrow from you. And effectively what I'm doing is I'm just shifting it that way. So I'm actually saying 10 tens, which is all that a 1 in that column meant. That's what borrowing is. Now I can go, oh yeah, I can do that. 5 from 13, let's see if I can get this right, 8. Is that right? Yeah. 385. The weird thing is with decimal numbers is we don't do this. We don't put leadings, we just say, oh, there's nothing there. Can't do that with binary, you have to be careful. Okay? That's the same process for binary, so let's have a look at it in binary. Everyone's happy with that, aren't they? Yeah. Right, okay. Now, why did I rub my tram lines out? Right, so I'm going to subtract 4 minus 3. What should the answer be? 1. Which should look like that. Okay, so let's write down 4. Let's write down 3. Put minus. Right, okay, so I'm going to do the same thing. Start the units column. I'm going to go, right, one from 0. Can't do that. I can, but I can't do the mechanics of it. So I need to borrow. Yeah, everyone happy with that? Got to borrow. Oh dear, there's a 0 in the next column. Right. I have seen some horrendous videos on YouTube of people doing this with like multiple borrows, and I'm going to show you a simple way of doing this so you don't cock it up. Right, really what we've got to do, we've got to keep going across until we find a 1 to nab. Okay, and we cross that out and we replace it with a 0, and then we borrow. Okay, but it's to here that we want to borrow. All the zeros we've gone past, cross them out and put a 1. The 0 does not exist, it's now been replaced with a 1. And then put your borrow there. So we've actually got 2. This is identical to what we did in the decimal. Okay? If you think about it, this should be the same equivalent number. Okay, right, so we have got a 2 and 2, which is 4. So it should be the same number. That's borrowing, just another way of writing numbers down. It just looks minging in binary. Right, so we've got 1 that we can now subtract from 2, which is 1. We've got 1 that we want to subtract from 1. Yeah? That's 2. 1 0. Yeah. Notice how I've written it though, Casper. I've crossed that out because I don't want it. I've crossed that out because I don't want it. This one I'm putting next to it. It's no different to when I did, was it 4 3 or something, wasn't it? When I had 4 3 and I went, right, reduce that. Well, it reduces to 0 in binary, and I put it there. I meant 13, didn't I? Same as that. Okay, so I just find that 1. I'm borrowing that 1, so make that column 0, cross out all the zeros in between, make them a 1, and then end up with that. You'll always end up with 2. That's the nice thing about the binary, I suppose. You're always going to get the same thing. So it's 1 minus 2, 2 minus 1, idiot, gives me a 1. 1 and 1, that's going to give me 0. Everything else is 0. That's the answer we were expecting. Okay? It's not pleasant. Okay? I'm showing you this. We don't actually need to do this, but I'm showing you this because sometimes the exam board do ask you to do subtraction and show you working. So they'll want to see you doing borrowing. But there is a better way. The CPU does not do subtraction. It uses 2's complement. I can rewrite this expression so that I don't have a subtraction. I can write 4 plus minus 3. That's mathematically exactly the same thing. Okay, let's check it works. It should give us the same answer. So let's write down 4 again. So I'm using the power of 2's complement. And there's a real big knock-on on this. If you haven't got to provide silicon circuits to do subtraction, that means you can use that space you would have used for something else. Maybe making your addition faster. Okay, or adding more features, or reducing the size of your CPU die, so you can reduce the power consumption and everything. But I need minus 3, so I've got to work out minus 3. Okay, so this is 3, but we want minus 3, so let's flip and add. So flip, 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 last one leave as a 1, so that's minus 3. So that's what I'm going to add. I'll copy it down properly this time, it might actually work. Right, so I'm going to add 4 to minus 3. So I get 0 and 1 is 1, 0, 0. 1 and 1 is 0, carry 1. And you can see again, it's going to roll that carry off. So 1 and 1 is 0, carry 1. 0, carry 1. And again, like I say, always show the example that you're not stupid. I was going to say you are stupid. Maybe you are stupid, I don't know. Maybe you want to give them impression that you're not stupid. So put a box around that answer and put an arrow next to it and put carry. Don't put Gary or Harry. Okay, make sure you say carry. If you put Gary, they're going to think you are stupid. Especially if you just spelt it with a double R. And I don't know many people that are called Gary that have got a double R. In fact, actually, no, I do know someone actually with a double R in there, Gary. So maybe you, I don't know. Maybe they think you just got carried away. But I would recommend the word carry. Oh God, why can't I just do a video where I just sensibly do something? I don't know. Okay, so we got the answer. We got a carry, but we're not worried about that. We're worried about the 5 bits, the bits we're working with. That gives me the answer of 1, which is exactly what we wanted. So we've actually just performed subtraction by doing addition. So we don't need it. Now, in terms of how the exam board, when they set a question, if they ask you to subtract and you use the 2's complement method and do addition, they have to reward you the mark. Because that's how the CPU does it. Okay? Everyone happy with that? Yeah? Right, final bit of subtraction. Back to that original problem that I gave you. 3 minus 4. So if we want to do... Oh, let me rub all this out. If we want to do 3 minus 4 and do it pure subtraction, so let's write 3. and let's write 4, and say subtract, it starts off alright. Starts off alright. We go, yeah, I can do this. Right. 1, 1. Alright, I need to borrow. Oh, doo-doo. Can't borrow. There's nowhere to borrow from. So I'm totally stuck. The standard way of doing is to flip your subtraction round and actually do 4 minus 3, and then whatever the result is, times it by minus 1. Which seems like a load of messing about to me. Okay, so let's do that. So let's do it the opposite way around. So I'm just gonna, that just doesn't work. So I'm gonna do the big number on the top, and I'm gonna subtract 3. But can you see I'm introducing loads of steps here? I'm making it complicated. Nobody likes it to be complicated. All right, so I'm gonna just do this. So not from 1. Oh, can't do it. So let's borrow. So cross that out, that's my first 1. Set that to 0, cross that out, just make it a 1. And bring the 1 you've borrowed here to make 2. So I do 1 minus 2, which is 1. 1 minus 1 is 0, and the rest of them are 0. So we get the answer 1, but we haven't finished. We've now got to do the multiply by minus 1, change the sign. And we know we can do that by just performing 2's complement. So let's flip, 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 get to the last one, leave it as a 1. And we get minus 1. So you can do it that way. But I think that's a bit poor. You're having to mess about, look at the numbers. So if you was doing this on a computer, you'd have to like, is the second number bigger than the first number? If it is, subtract them the opposite way around and then do 2's complement. It seems a bit crazy. If you're just going to do some arithmetic, you just want to do the arithmetic. You don't want a load of logic involved before you do the arithmetic. Okay? So let's have a look what happens if we do it with 2's complement. So we go back and we just want to do 3 minus 4. How else can we write 3 minus 4? 3 plus minus 4. Yeah? Right. So let's write down 3. So 3's fine. Get sick of writing down 3 in a minute. And now I've got to write down minus 4. I don't know what minus 4... I do, but I don't know what minus 4 is in 2's complement. So I'm going to write down what 4 is. And then I'm going to do 2's complement to find minus 4. So I'm going to go flip, flip. That's the last 1. So leave it as a 1. Everything else stays the same. That is minus 4 in 2's complement. 5 bits. So let's write that down. And you can probably see straight away that this is going to work and give us minus 1. So we go, not on 1, not on 1, not on 1, not on 1, not on 1. Minus 1. It just works. I didn't have to do any working out beforehand. Just did it. It's a shame you can't do that in normal maths. It'll probably make a few things more easy. But it just works. Okay? So by using 2's complement, we simplify arithmetic. It's not easy for humans to read, but who cares? The computer don't care. It wants things in a format it can do. And you'll see loads of things this year and next year that look horrendous for us, but the computer goes, yeah, no, this is easy. Piece of cake. It's a piece of cake. Piece of cake for me. Horrible for you. Piece of cake for me. Anyone got any questions about that? Right, I'll stop the tape, assuming it's still going. Well, it's not a tape, is it? It's like a webcam. On the workstation as well. And I'll just give you a few to do now. I'm going to give you the questions in decimal,